Hello, my name is Cheng Wei, and today my topic is storage performance scoring system, and let's use one score for all the storage performance testing. Um, at the beginning, let me introduce the background and the motivation a little bit for those of you who do not have the storage background or the performance background. So people usually doing storage performance testing by specifying the units or the I/O patterns in this green area, so which including block size, read-write ratio, sequential random ratio, number of parallel I/O, working set, testing time. Then they will get the results actually using the following metrics. The first of the IOPS, which is I/O per second, throughput, average read latency, write latency, 95th percentile. So after user getting this certain number of results, intuitively they should be able to figure out whether the number of performance testing is good or not. However, things gonna be pretty complicated when they're running some max workload. For example, if they're running 32 KB testing along with 256 KB testing, they got, let's say, 7,000 IOPS, and most of the storage administrator is not able to figure out whether this number means good or not, so which gonna block them from investigating is there any potential issue in their storage underneath. Okay, so what I would like to do, I would like to use one score to score all the testing result along with its I/O pattern. So first of all, I'm I'm going to do the filtering and grouping the data. What it does basically, the filtering data is to filter out the outliers from I/O pattern. So for example, the user send over back um, 10,000 records, and probably, the 1,000 out of the 10,000 is kind of invalid because they have, too small active working set, very few number of parallel I/O, as well as too short testing time. So, in this case, I'll just filter out those I/O pattern. I just keep the valid ones. So in this case, in the gray area, you can see in this table is the I/O pattern I'm using for the following process, which is grouping the data. And as you can see, we grouped our data into four categories. Basically, initially we call the four corner, which is from I/O pattern perspective. It's really easy to see. It's sequential read, sequential write, random read, random write, which is as a four corner or four aspects of our storage pattern. So in this case, each storage testing I/O pattern can be divided across those four categories. So for example, 128 KB, 70 read, 30 write, 60 sequential, 40 random can be divided into those four corners by using zero weight or percentage. And the next step is we should basically choose a block size, which is a standard block size to represent all the other block size, because each block size have different characteristics. They have like different focus. So we should have all the block sizes aligned with only one standard block size to represent the performance. So for block size, I actually choose a 64 KB as a block size for everything. So in this case, all the other block size has to be aligned with 64K. Find out the equations. So let's move to the third part of this poster. So find out the equation of block sizes. Which we need to do is we need to find out what's the random sequential ratio, parallel I/O, and hardware information to pair those data together. Then I'll just grab query out all the pairing samples, pick up 70 as a testing training set and the 30 as a validation set. Then I use Python to figure out whether they're a linear regression, then get the equation from 8K to 64K, and I'm using MAE to get the error evaluation. So here I got the training error is 1400, while the test error is 1300. They're not far from each other, so I'll say this linear regression testing is pretty valid. And the very last, I'll just find out the equation, by using the Python. So here, as example, I can find equation of from 8K to 64K, from 70% read to 100% write. I can figure out the equation is listed below. And last step, we basically need to define a scoring system, basically how we should score the systems. So initially, you have to query out all the 64K four corner number for basically 100% write with and 100% read with 100% random and 100% sequential, which you can see those four metrics in this table. So I'll just query out all the data here. And in this case, I got 18 samples for 100% random, 100% read for 64 KB, and 53 samples for 100% random, 100% write. So, as you can see, we have such a relationship between the IOPS and latency as well as the number of parallel IO. So I think it's going to be a good idea for me to use the IOPS divided by number of parallel IO as a score for each of the corner for the random testing, because random is basically focusing on the IOPS. If we're doing sequential, we need to use the throughput divided by number of parallel IO as a score of each corner. So, and basically I'm using the each of the score as a testing data, you minus the minimum data and divided by max, and subtracted by the minimum data, and get 100%, get 100 timed. So in this case, we will have all our scores from 0 to 100 based on the existing data. So finally, we can get, okay, this 8K 70% read data, we can give it a score is 29.45. And initially, let me just talk about this workload very briefly. So customers, they can just run testing from their environment, and we are able to have them ship over their IO pattern testing result in the blue part, as well as their environment information to our database. As you can see, first of all, I filter the data, and I divide each entry into 4 groups, and then I got sequential read, sequential write, random read, random write. Then I'm using linear regression to figure out those block sizes, how does block size relationship along with the 64 KB block sizes. So I can basically use 64 KB 100% read, 100% write to represent other block sizes and other read-write ratio. And then I'm gonna use MAE to evaluate the errors. Then I have to find out the equation of the 64 KB to represent other blocks as part data. And after scoring these 4 corners of 64 KB 100% read, 100% write, I can get the score from 0 to 100. And if I have a new sample comes in, I can basically first of all just get into the 64K representation, then just get the score very easily by using this equation. Okay, thank you.